Good day. So, this is our video presentation for our RSL Motorsports company. This is our company profile. The RSL Motorsport is a prominent automotive industry company specializing in the design, manufacturing, report, tuning, sales, and procurement of cars and car parts. As a proud family business, owned and operated by the Mendoza family, RSL Motorsports has built a reputation for exceptional craftsmanship, innovation, and customer satisfaction.
Functional areas. This includes sales and marketing, which promotes and sells vehicle parts to consumers. This includes market research, advertising, and sales strategies. Finance and accounting. This manages financial operations, including budgeting, financial planning, and cost analysis. Quality assurance, which focuses on maintaining and improving product quality throughout the entire manufacturing process. And lastly, human resources or HR, which handles employee recruitment, training, performance management, compensation, and labor relations. Process flow. First, supply chain management, which sources raw materials, building components, and assembling vehicles. Second, manufacturing, which assembles components into finished vehicles, as well as quality control and testing to ensure that each vehicle meets the required standards. Third, service and maintenance. This ensures that vehicles continue to function properly and meet the needs of the customers. And lastly, distribution. After manufacturing the vehicles, they are distributed to dealerships or to the direct customers. So these are organizational chart. So this is a diagram that visually conveys our company's internal structure by detailing the roles, responsibilities, and relationships between individuals within the chart. Forms and reports used. This includes sales order form. So this form is used to acquire comprehensive details regarding the customer's vehicle purchase. This includes model of the vehicle, the price, financing terms, and any additional features or upgrades. Repair order form. So this form is used to gather information when a vehicle is brought in for maintenance or repair, including the customer's contact details, the vehicle model, and the nature of the problem. Vehicle inspection report. So this report captures details such as the vehicle's mileage, condition of tires and brakes, and any other issues that require attention. Quality control report. This report is also imperative to track defects and issues in the manufacturing process. Production schedule report. This report is utilized to strategize and coordinate production activities, ensuring that vehicles are manufactured proficiently and delivered on schedule. Inventory report. This report is utilized to track and monitor the availability and location of parts and materials needed for manufacturing and repairs. Warranty claim form. When a customer makes a warranty claim, this report is used to obtain vital information such as the customer's contact details, the nature of the problem, and any necessary repairs or replacement.
And for the chapter 3, which is the system development life cycle, first is the planning. To identify the needs and objectives of the database system, the group gathered necessary requirements through interviews with RSL Motorsports manufacturers, dealerships, and employees. This includes inventory management, customer relationship management, maintenance tracking, and sales and marketing analytics. Second is the analysis. Requirements gathered are analyzed to determine the feasibility of the database system. This will help create an immense understanding of the system needs to accomplish and the technical and operational constraints it may encounter. And next is the existing systems. The OBD or onboard diagnostic systems in modern vehicles is a standardized computer-based system that monitors and diagnoses components and systems. It detects malfunctions affecting performance, emissions, and safety. It consists of sensors, an ECU, and a diagnostic connector. Sensors collect data on parameters like engine speed and coolant temperature processed by the ECU. Malfunctions generate diagnostic trouble codes, accessible via a diagnostic tool connected to the connector. OBD has evolved from OBD1 to OBD2, mandated in the US from 1996. It enhances vehicle diagnostics, emission control, and enables advanced diagnostic tools. OBD is crucial for maintenance, performance monitoring, and emission control in the automotive industry. For the potential risk of the OBD, first is the data privacy and security. OBD system collect and store sensitive vehicle data, including diagnostic information and performance metrics. If not adequately protected, this data can be vulnerable to unauthorized access, misuse, or cyber attacks. Breaches in a data privacy and security can lead to personal information exposure or potential manipulation of the vehicle system. Second is the malicious exploitation. As OBD systems become more connected and integrated with other vehicle systems, there is a risk of them being targeted by malicious individuals or hackers. If an attacker gains unauthorized access to the OBD system, they may be able to manipulate or tamper with critical vehicle functions, leading to safety hazards or unauthorized control over the vehicle. Third is the false or misleading diagnostic information. OBD systems rely on sensors and algorithms to monitor and diagnose vehicle performance. However, these systems are not infallible and can occasionally generate false or misleading diagnostic trouble codes. This can result in unnecessary repairs or incorrect assessments of vehicle conditions, leading to inefficiencies and financial losses. Fourth is the dependency on diagnostic tools. Proper utilization of the OBD system requires the use of specialized diagnostic tools. If these tools are not accessible or not utilized correctly, it can hinder effective troubleshooting and repair processes. Additionally, the reliance on a specific diagnostic tools can create dependency on manufacturers or service providers, limiting flexibility and increasing costs for automotive businesses. Fifth is the compatibility and standardization issues. The OBD system has evolved over time, and different generations and variants exist, ensuring compatibility and standardization across various vehicle models and manufacturers can be challenging. Differences in communication protocols, connector types, and data formats can lead to interoperability issues and complicated diagnostic and repairs. Lastly is the regulatory compliance. OBD systems are subject to regulatory requirements, such as emission standards and reporting obligations. Non-compliance with these regulations can result in penalties, legal repercussions, or damage to the reputation of automotive businesses. And next is the detailed system design. The automotive industry detailed system design, outlined in the provided diagram, involves multiple stakeholders and processes to ensure efficient and effective operations. Let's break down each component and its role in the overall system. First, the clients. These are the customers who bring their vehicles to the automotive service center for maintenance, repair, and other services. Second is the secretary. The secretary acts as a communication hub between the clients and various personnel within the organization. They handle appointment scheduling and manage client inquiries. Third is the appointment and scheduling. The secretary interacts with clients to schedule appointments based on their preferred time slots and the availability of resources. Next is the vehicle check-in customer approval. Once the client arrives at the service center, the secretary facilitates the check-in processes. This step involves gathering relevant information about the vehicle and obtaining customer approval for the services required. Next is the assessment and cost estimate and finalization and billing. After the check-in, the secretary communicates the customer's request to the assessment team. The assessment team, which could include technicians or mechanics, inspect the vehicle, identifies the necessary repairs, and estimate the cost. Once the assessment is completed, the secretary shares the cost estimate with the client's approval. After the client's finalization, the secretary generates the invoice and facilitates the billing process. Next is the finance and accounting officer. The finance and accounting officer handles financial transactions, verifies invoices, and ensures accurate accounting for the service rendered. Next is the business owner or the manager. The business owner or manager oversees the overall operations of the automotive service center. They monitor the efficiency of the system, make strategic decisions, and ensure customer satisfaction. Next is the Chief Operating Officer or COO. The COO is responsible for managing the day-to-day activities of the service center. They coordinate with various departments to ensure smooth operation and efficient resource allocation. Next is the Chief Mechanic. The Chief Mechanic oversees the technical aspects of the service center. They are responsible for assigning tasks to mechanics, ensuring the availability of necessary resources, and maintaining quality standards. Next is the resources. It includes tools, equipment, spare parts, and other materials required for vehicle repairs and maintenance. The chief mechanic manages the availability and allocation of resources. Next is the mechanics. Mechanics are skilled technicians who perform the task related to vehicle repair and maintenance or other services. Next is the quality control. The quality control process involves ensuring that the service provided meet the required standards. The mechanic, along with the quality team, performs inspections and tests to ensure the work is completed correctly. Lastly is the task. The task refers to the specific work assigned to the mechanic based on the assessment. This could include tasks like engine repair, brake replacement, oil change, or any other vehicle-related services.
This is our implementation. Number 1 is the ERP system is developed and customized according to the detailed system design specification. Number 2 is configuration are made to align with the company's specific requirements and processes. Number 3 is extensive testing and conducting including unit testing and integration testing and user acceptance testing. Number 4 is end user training is provided to ensure employee can effectively use the ERP system. The system is gradually implemented in phases starting with a pilot rollout in selected departments. And our maintenance is number 1 is ongoing system monitoring and performance optimization to identify and resolve any issue. Number 2 is continuous support and training for end user to maximize its system and utilization. Number 3 is regular update and enhancement to address a changing business needs technological advancement. And number 4, data backups and security measures and system audits to ensure data integrity and compliance. Number 5 is feedback gathering from using to identify areas for further improvement and optimization.
For RSL Motorsports database design, the company's information system diagram will circle around database initial study, database design, which in this case we will be using entity relationship diagram, implementation and loading, testing and evaluation, operation, and maintenance and evolution. First off, the database initial study. The group will identify the data requirements for each module of the ERP system, analyze the existing data sources, and determine the data that needs to be stored in the database. Determine the data volumes, types, relationships, and access patterns. Define the goals and objectives for the database system. For RSL's ERD, I will be discussing the relationships of each entity. The process manager. The process manager is mandatory, which manages the company's employees. Hence, they have the relationship of one to many. The secretary records the necessary information of each employee. Hence, this relationship is one-to-one. The business process team occupies each employee. As seen on the diagram, they have many-to-one relationship. For the chief operating officers, they handle the employee process of each employee. Hence, a many-to-one relationship. Last but not the least is the mechanic process which serves the employees. This is a many-to-many relationship. For RSL Motorsports Database Management System, this is our data dictionary. Implementation and loading. Our group will create a physical database based on the database schema, implement the database tables, columns, data types, and constraints, load initial data into the database such as, but not limited to, car specifications, inventory records, and customer details, and establish a data integration process to connect the database with the other modules of the ERP. Here is Vincent Umali to discuss the remaining information system.
We use MySQL to make the database for Russell Motorsports. There are 6 tables, namely Business Process Team Table, Chief of Operating Officer Employee Process Table, Employee Table, Mechanic Process Table, Process Managers Table, and Secretary Process Table. The attributes within the Business Process Team Table are employee number, last name, middle name, and first name, employee email, contact number, team code, and work code. Up next, we have the attributes within the Mechanic Process Table, which are work code, description, and day rate. Then the attributes within the Chief Operating Officer Employees Process Table, which are work code, description, and day rate. Attributes that reside within the Secretary Process Table are work code, description. As for the Process Manager Table, we have the attributes work code and description. Then lastly, for Business Process Team Table, we have the attributes team code and description. Testing and evaluation. Perform testing to ensure the database functions are expected. Validate the database against the requirements and specification gathered during the analysis phase. Conduct performance testing to assess the responsiveness and scalability of the database. Gather feedback from users and stakeholders to identify any issues or areas for improvement. Evaluate the effectiveness and efficiency of the database in supporting the ERP system. Operation. Deploy the database in the production environment. Provide access to authorized users and implement security measures to protect data. Monitor the database performance and optimize query execution. Handle regular data updates, inserts, and deletions as per the business processes. Establish backup and recovery procedures to ensure data integrity and minimize downtime. Maintenance and evolution. Provide ongoing maintenance and support for the database system. Continuously monitor and maintain the database to ensure its performance and stability. Perform regular updates and patches to address security vulnerabilities and system improvements. Optimize database performance by analyzing query execution plans and index usage. Accommodate changes in business requirements by modifying the database schema and data model. Continuously evaluate the performance of the database and align it with the evolving business needs. And that's it for the video. Thank you for listening to our presentation.